We're going to talk about concavity here, which is kind of describing the curviness or how much we see the slope change over time. So the first thing we're going to look at is concave up. A function is considered to be concave up or positive concavity when the second derivative is greater than 0. If you want to look at that, we think about that kind of like, if you want to think about it, it's like a smiley face, so hence positive, or concave up, the smile goes up, if you like to think about it that way. Concave down is the opposite. A function is considered to be concave down or negative concavity when the second derivative is less than 0. And this is like, a frowny face. So that's, we see it going down or having kind of negative connotation there. And so if we see this, we can look at kind of both of the behaviors we've talked about together, increasing, decreasing, and concavity. So we see that in this first section here, the first derivative is less than 0 because the function is going down, but it's concave up because this is like, the left half of a smiley face. Then in the middle section, this first middle section, we have them both positive. It's increasing and it's concave up. So we see a curving up. Then we see the flip of that. So we have still increasing behavior, but kind of like the left side of a frowny face. So that gives us the concave down. And then on the right, far to the right, we've got concave down and decreasing because we have kind of that frowny face behavior and it's pointing downwards. So last thing to note here about concavity is that the inflection points are where the concavity changes. So if it goes from positive to negative, or from negative to positive. And this will always occur where the second derivative is equal to 0. So we can't switch from positive to negative or negative to positive without the second derivative being 0 or undefined. But like critical points, f double prime of x equaling 0 or being undefined does not guarantee an inflection point. So just like critical points did not guarantee minima or maxima, second derivatives equaling 0 does not guarantee an inflection point. You'll have to actually check, is it concave up on one side and then concave down on the other? Because you can have something like this. Let me see if I can draw it. So in this whole section here, the second derivative is 0, but it's concave up on one side, concave up on the other. And so this section in the middle would not be an inflection point because it didn't change between the two. And that will close us out there.